Welcome back, Science 10. You should have finished the first part of the ionic compounds. That's what we did in the last video. We looked at the first part and looking exactly at how ionic compound formulas are made. And today we'll finish off with that, and we'll look at naming them as well. So this first page we completed, looked at what an ionic bond is, or the attraction between positive and negative ions. And then we did these first two formulas together. So basically, calcium and bromide, looking them up on the periodic table, seeing what the ionic charge is on each of them, and basically trying to balance all the positives and negatives. So for example, to recap, calcium has a charge of 2 positive, bromide is -1, so we can pick those up right from here on the chart. And as you can see, we'd have to have 2 bromides to balance 1 calcium. 2 positive, 1 and 1, 2 negatives. So the formula illustrates how many of each we would need to have. So calcium bromide is CaBr2. With copper 1 sulfide, copper 1 is positive and positive. Sulfide, if you look back at the table here, sulfide's 2 negative. So as you can see, we'd have to have 2 coppers to balance 1 sulfide. So moving on to over here, aluminum selenide. So if we look at aluminum, selenide is Se, and the more of these questions you do, the easier it will be to know the formulas right off the bat. For a while, it'll be a little bit of a struggle looking at the periodic table. So aluminum and selenide, if we go back, aluminum is right over here, 3+, and selenide, I don't have it on here, but if you take a look at another periodic table, it falls right here, right below the S. So if we take a look, I'll maybe just write it in, maybe you should too, just so we can have it in the future. Selenide is right there, and of course it's 2 negative, just like over here. So if we move over here, I'm just going to copy this negative charge here and place it there. So aluminum, or selenide is right there, and of course aluminum is 3 positives. Now, this is likely as difficult as it gets. 3 and 2 definitely do not balance out. But if you think in terms of math terms, what's the lowest common multiple that 3 and 2 go into? It's 6. So all you need to do here is just take the larger charge and maybe double the amount that you have. So if I have another aluminum, I can see that that's a total of 3 plus 3 is 6, and 2 goes into 6 3 times. So if I have a couple of more selenides, just like this, two and 2. Grab my negative charges there. So you just basically keep adding some more until the charges balance out. So if we take a look here, 3 plus 3 is 6. 2 plus 2 plus 2 is 6. Just move my negative out there. There we go. So that's basically how you do it. You just simply add one of each until you can kind of see how they would balance out. So the formula for aluminum selenide would be, well, once again, in the final formulas, if you look up here, we don't have charges. Basically, you just have the atoms or the ions and how many of each. So here, it's not a 1-to-1 ratio. We can see that we have 1, 2, we have 2 aluminums, and 1, 2, 3, 3 selenides. So the final formula for aluminum selenide is Al2Se3, showing a summary of what happened over here. Okay, moving on to magnesium and oxide. So of course magnesium is Mg, oxide is O. Looking back here, magnesium's 2 positive, oxide's 2 negative. So that's relatively easy here. So 2 positive and 2 negative. Pull my negative sign from over there. So you can see 2 positive balances with 2 negative. So 1 magnesium will balance nicely with 1
Ms. Sykes,
oxide.
would you call the office, please?
So hopefully Ms. Sykes gets to the office. So MgO, that would be the final formula there. Because they already balance out nicely. 2 positive and 2 negative balance out. So just 1 Mg and 1 O, that's it. So as you can see, that's the key to writing formulas for these equations. Looking up what the ionic charge is, and then from there figuring out what you need to do to balance them. Okay? Writing names, a little bit easier. You just simply have to identify what you're given and then simply find the name. So here we have K, and here we have O, and then don't get confused here. What is the 2 here? Well, if you look back at why the 2 is there, potassium is +1, and what's the other one here? Oxide. Oxide is 2 negative, so you can see that I would have to have 2 Ks for every 1 oxide to balance out. 1 plus 1 will give me 2 positives, and then my 1 oxide is 2 negative, so that's why the 2 is there. So don't get thrown off by the 2. So, quite simply, potassium oxide. That's it. Nothing too crazy and wild about that. If you look over here, Be and F, Be and F, so beryllium here is 2 positive, F is 1 negative, so of course to make these balance out, for every 1 barium, which is worth 2, I'd have to have 2 fluorides, because they're each worth -1. -1 and -1 would give me -2. So that's why I have to have 2. So that's why that little subscript 2 is there. So beryllium, careful with the spelling there. You may want to spell fluoride instead of fluoride. So beryllium fluoride. Easy. Over here, SnCl4. SnCl4. Now, you won't see Sn over there, but it's one of these middle elements here, one that has more than one option. So you can see here at this chart, Sn could be 2 positive or 4 positive. So it's either one of those tins is either worth 2 positives or 4 positives. The trick to figuring out which one it is looking at the other element. And the other element in this case is chloride, and we need 4 of them. So let's take a look. Chloride is worth 1, and I need 4 of them, which means that's going to be a total of 4 negatives. So the 1 tin that we have there must be the 4 positive. Because if I need 4 negatives to balance 1 tin, that 1 tin must be worth 4. So that's the key. Take a look at what it's paired up with. So tin, 4, chloride. So we put that Roman numeral 4 there to distinguish between which version of tin it is that I'm using. The last one over here, Na3N. So it looks like here I need 3 of these NAs to balance an N. Na is worth +1, N is worth 3 negative, so that makes sense. To balance one of these N's, which is worth 3 negative, I need 3 of these positive ones. 1 plus 1 plus 1, 3. So that's why the little subscript 3 is there. But naming it is just simply sodium nitride. So notice these all end in ides, And that goes back to the rule here that all of these nonmetals, the ones that gain negative charges, their names adopt the "ide" ending. And you'll always have access to this list, so you don't have to memorize them, but you'll get to know them as you go along. Okay? So those are the practice questions I wanted to do with you. The next thing to do now is on the next page here, run through these ones. So the first question here is, what are the formulas here? So if I were you, I would just simply find the magnesium ion, find the oxide ion, write them above here, and then you can figure out how many of each I need, and then answer the question there. And then the easier part here, naming. Don't forget that if they are one of those transition middle elements, that you have to have the Roman numerals there to tell me which one it is you're using. Okay, we'll see you next time.